Hey everybody, what's up? I'm going to talk to you about my neck hurts. Phase changes, okay? Now, we've already talked about phase changes before. What are the three most common phases of matter around you? Yep, it's solid, liquid, and gas. And if you remember at the very beginning of the year, we took some ice and we melted it. And when it was melting, it took a long time. Then it turned to a liquid. It heated up real quickly. Then it was boiling. It took a long time. Then eventually it was a gas. So this one had, this was time going by. And then we had temperature, right? So we made like a line graph of this. And it was about phase changes. Well, we also realized that, hey, if you look at this, graph, you could figure out if this graph we made was about water. If where it was melting was at 0 degrees Celsius and where it was boiling up here was at 100 degrees Celsius, you knew it was water. Well, that's right. I mean, this is phase changes, okay? Well, now we're going to be talking about phase changes, but with another dimension added. And that other dimension added is pressure, okay? The other dimension to this now will be pressure, okay? Now normally, and when I say normally, I mean normal. Normally, the pressure you're in is like 1 atmosphere. Like in the room, right here, the pressure on me is about 1 atmosphere, or 101.3 kilopascals, or how many millimeters of mercury? That's right, 760. So this is normal pressure. So under normal pressure, we know that water freezes at 0. We know that fresh water boils at 100. But what if we make some abnormal conditions? We can do some pretty cool stuff. Let's take a look at something. All right, check this out. I've got a little water. Got a little water in here. I'm gonna run this. I'm gonna run this vacuum here. Right. So the pressure in here is gonna drop. Check it out. I'm gonna put this lid on here. I'm gonna stopper it up. All right. I've got a stopper on here. And if we look there closely at the water, you'll be like, oh, that's not very interesting. Nothing's happening. Nothing's happening. Well, let's let it go for a little bit. Let's let it go for a little bit. So in here you can see I've just got some water. I've got a lid on it. We're creating a vacuum, so the pressure in here is dropping, okay? If you start looking closely, you'll see there's some magic happening. And guess what? That water's boiling. That's pretty cool, right? So I better not touch this. Well, I can touch it, because guess what? It's cold. It's fine, it's cold. Well, that water was in there boiling. The temperature is not 100 degrees Celsius. The temperature isn't 100 degrees Celsius at all. So you're like, what's the deal? Well, we're not under normal conditions. Okay? We're not under normal conditions. We definitely weren't under normal conditions in that flask. If you were in that flask, like your ears would pop, your blood vessels in your eyes would burst. It would be pretty rough on you if you're in there, because the pressure in the flask was super, super low. Let's take a look at a graph you might be interested in seeing. Now, this is a phase change diagram. This is a phase change diagram. And all phase change diagrams are somewhat the same. This section over here on the left is going to be your solid when it's a solid. And the section right here In the middle, it's going to be when your substance is a liquid, and then the gas is going to be down here. So this is pressure, and this is temperature. When you're over here and you're a solid, you can be at really high pressures and low temperatures, okay? When you are here as a liquid, you're kind of pressure and temperature moderate. And then over here, gases can be at really high temperatures, even, and still be gases at low pressure, all right? So these are our phase changes. Now this would work with water as well. Let's take a look at a different phase change diagram. Let me grab it right here for you. If we take a look right here, this is a general diagram, right? Solid, liquid, and gas. Okay, and I'm gonna move you towards one that's got a little more specific information on it. All right, grab that, put that down there just a little bit, and boom. Okay, I want you to think about this graph right here. Look at the pressure, 101.3 kilopascals. If you look at this, something about this graph should be obvious. That's right, this is water. Look, at normal, or 1 atmosphere, at normal pressure, if you go over here, it changes from the solid section to the liquid section, right here at, guess what, 0 degrees Celsius. So this is the melting point. Makes sense? And you have a liquid water here. And then at normal pressure, if you go over to here, boom, this is where it changed from a liquid to a gas. Guess what? Beep, boop. That's at 100 degrees Celsius. So you can look at a graph like this and tell if it's fresh water or not, just like our earlier graph from earlier in the semester. Okay? So where were we when I was just boiling the water in the flask? Well, we were boiling the water down here. So we were down here at about room temperature, about 23 degrees Celsius. Okay, and we changed it from a liquid to a vapor right there. So the pressure was very, very low inside that flask. Does that make sense? So now, when we're talking about phase changes, we're not only talking about solids, liquids, and gases, not just talking about melting point and freezing point due to temperature. We're also talking about these things, these points changing under different unusual pressures or pressures that you're not used to. You're going to have a worksheet on this. It's very straightforward, okay? It's very straightforward, and good luck on that.